All right, hey everybody, it's 6:30 a.m. Pacific.
Hey!
Yeah.
We've been going for how many hours now?
Um,
What is
gosh,
this?
it'd be 21 hours, I think. Is that
21?
right? Something close to 21 hours.
9 a.m.
Um,
minus.
and
21.
we are currently at 218.5 million transactions since the start.
218 million?
Right. So if you get in there,
Put that in
make,
context for
make
me.
some guesses. It's
Like
more than 10 million an hour,
Okay.
and around between 27 to 3,000 per second, continuous that over the whole time. Right?
So what, like Visa, the Visa network. What would be like the sustained transactions on a network like that?
Apparently, from what I've read, that it is approximately 1,700 to 2,000 per second average. That's
Wow.
not peak, right? You know, they have peak too, but
Okay.
sustained average is around 1,700 from what I read.
And then like other blockchains, like what would like a Bitcoin have?
Bitcoin is somewhere between 5 and 14, something like that.
Transactions?
Right, per second. Yeah.
Not hundred,
No,
not
right.
not thousand, but
Right.
okay. And then like an Ethereum?
Ethereum, I did know. I don't know. I'm too tired to remember
Okay.
half of these. I know Ripple
It's
was
like a couple hundred,
around
right?
around 1,700 to or 1,400, something like that.
Ripple was pretty good in comparison, but Ethereum was a little bit lower.
Mhm.
So that's pretty nuts for the transactions.
Yeah.
And this is sustained, right? So
Right.
like it's one thing to do peak or burst, but this is
And that's what we
consistent
wanted to really
over a period
see ourselves, right? Just
of
to
time.
kind of, really run it over a long period, and see what happens.
I'm pretty amazed at like the scale that we can get from the solution. It's kind of gives us a good platform for new the next wave of technologies that are rising, like IoT and those things.
Right.
Like this type of scale is going to be necessary for the IoT as we start to deploy like 5G and IoT devices. You need to have a different level of scale, right? Like think 10 years ago when you thought like, well, maybe I'll have a laptop and a phone. So maybe I need 2 or 3 IP addresses on my home network. And if I think about my own home network today, I have, lots of IoT devices, Alexas and Siris and TVs and everything else. I never would have thought that I would have had to run out of a Class C at home, but
Big Brother has to be able to talk to each one of those devices.
but
So.
I've been driving up the number of devices, and so being able to support large scale is going to be really important for IoT devices. The clarity of that information is really important, right? So it's important not to just have lots of information, but to have information that you can make decisions on, right? So having trusted, validated information that you can trust is one of the key things of when we're building IoT solutions and
Right.
the next generation of solutions.
Right, and is that the next demo?
It is.
So all
It
right, so
is.
I'm gonna step away.
All right.
Jonathan's coming up at 7 about patents, so you're gonna go over IoT. Let me know if you need anything. I'll be here. All right.
Okay. We'll see you later, Joe. So in our IoT solution, one of the things that we've done is we built a integrity smart contract for different IoT devices. And so I won't walk you through the whole entire smart contract here, but I'll kind of walk you through the gist of the solutions. And the solution is available as open source from Dragonchain for you to build on top of the chain. We haven't put it to the GitHub yet, but it will be available. So if you need to get it sooner than later, reach out to us. The software integrity contract runs on Dragonchain allows you to have different versions of software ledgered onto the chain and then authorized over a period of time. So it's like having each submitter can authorize and sign for their approval, and give their private key to approve for that stage. And so, for example, an organization may have a developer that may need to be able to sign to say that, okay, I actually created the code. You may have someone in test be able to say that I did a QA on the code itself. And you may have someone in security or governance or another group sign off on the release for the code itself. And each of those individuals can sign, or maybe 2 of the 3 different solutions can sign within a period of time to be able to release the software. And so what we do is we build a software tracker. And so what we can do is build containerize the code repository, and so we've created a tracker on there. In this case, what we've done is we push out the software itself. We have the image URL, and we can deploy the contract onto the Dragonchain. We deploy the contract out, and then we can start to sign the contracts through each of the different chains. And so we can actually have integrity over the chain of custody of how the code was released into the process. So the first step is to get the latest SDK. We then push out the SDK out to the solution. We register for a Dragonchain console. We then get a list of approvals of who's allowed to approve a list of approvers for the system itself. And then once we have those approvers, like in this case, we have the payload of the different individuals. They can go through and add new keys to each of those approvers, so we can match up the keys to say this person with this private key is that signs it is approved, and then we can validate each of those different solutions. And so this is really important in the deployment of IoT devices as we think about the things that we've been seeing with like rooted video cameras and untrusted firmware that's happening on things like video cameras and other IoT devices out there. Being able to track the process in which firmware was written and deployed is really critical to be able to deploy these solutions. And so it's one of the neat things that we're able to do. The other thing that's kind of neat about IoT devices is new definition of where computing is being done, whether it's being done out on the edge, whether it's being done out in the compute, or whether it's being done out in your own on-premise data centers. We're seeing new models of ways that people are deploying these solutions with AI arising in conjunction with IoT. We see new sets of data being pulled out there. And so smart contracts can allow you to move and share algorithms in new different models. So for example, with IoT devices, lots of data may be produced out on different edge devices, whether the edge is a metro edge, or whether it's the actual IoT devices, or different new topologies that are arising. We can start to push algorithms out to that data itself, where it may make more sense to filter and reduce some of that data sets, or make decisions on the data at the point where it's collected. And so one of the things that we realize is that it's not always the same parties or the same companies that are building the algorithms that are wanting to use the algorithms. But there's a trust problem or trust challenge of being able to use those algorithms in different environments, and making sure that they're confidential, that they're not being stolen, that the intellectual property is protected, that the data is being protected, and that you're not shipping private, personal, or sensitive data around to third parties. And so what we can do with smart contracts is we can take a Dragonchain and pull it up adjacent to the information that's being collected by those IoT devices, and take smart contracts and allow for a platform for different parties to bring their data and their algorithms together in a confidential computing type environment to bring those data together. I've been playing a little bit with homeomorphic encryption, and being able to take data and information and being able to exchange it confidentially without parties knowing each other's secrets, yet getting the output of the actual algorithms being executed. And so now there's homeomorphic encryption, which is fantastic, which blockchain is really unlocking, as being able to take out the trusted entities and rely on protocols and technology itself as the mediation platform. But algorithms can be weakened, they can have vulnerabilities, and so by using Dragonchain and smart contracts, we can break up that algorithm and have both the process enforced through smart contracts and the business logic of the exchange, and then combine that together with the technology of homeomorphic encryption to be able to provide the encryption controls and the protection from a algorithmic standpoint to protect it. And so by layering those on, we really combine and hit really a sweet spot in where we see compute happening at the edge on IoT devices. There's other interesting things that we're doing with IoT, in the fact that we have decentralized identity with our Dragon Factor solution. Our Dragon Factor solution, we've been making a lot of progress in that solution and being able to create a private key, being able to validate who you are, being able to have third-party verifications or attestations of who you are. And if you apply that to the IoT world, it allows you to have devices that are owned by individuals. So me as an individual can own an IoT device, and that IoT device can sign or verify different types of environmental environments or information and pass that through a validated standpoint. By using decentralized identity, it allows us to take out third-party validations and allows us to do peer-to-peer communications in a way that's much more efficient and doesn't require third parties to be involved in our transactions. And so it's a really neat ability to verify and validate transactions that are happening from IoT devices in a really lightweight, low footprint type of solution. I think there's going to be lots of interesting things that we're able to do with the negotiation and being able to have like IoT devices use that decentralized identity to be able to access secure stores. So an IoT device can actually access things like a data store or a vault of information for that IoT device. We can have things like provenance and location history of those IoT devices. So we can better rely on the data that's being produced by these devices. So if you're interested in working more with blockchain and IoT devices, come reach out to Dragonchain. We have consulting services that we can help you figure out and deploy these solutions. We can help validate transactions. We can help validate the firmware and the release of those softwares. We can help with bringing different compute and processes together, so bringing algorithms together with the data and being able to mine that data in a way that makes sense and react to it through data streams. And so I'm going to go ahead and log out now. We'll go to a break in 15 minutes. Be sure to tune in. Jonathan is going to be walking us through the patent process. He has lots of valuable information. Every time I talk to him, I learn something new. So don't miss it. Jonathan's amazing. Thanks.
Good morning. We're back at 7 a.m. Pacific time here at Dragonchain headquarters, and excuse me, we're at 223 million plus transactions running continuously since 9 a.m. yesterday. And I'm super pleased to be joined by Jonathan Olson, who is our patent attorney. And he's going to go through some really fascinating stuff. And I hope you're seeing this Instruments of War up on the screen. So this is not going to be your usual patent dry. We've been talking about our interchain interoperability. And now we're going to get the legal technical details from Jonathan.
Well, I'm going to try to not let it be dry. But anyway, it's kind of patents are a thing, so it's a little different way to look at your creations, at your accomplishments, and kind of formalize it. But I thought I'd put Smaug up on there to set the tone as to why you take your trade secrets and turn them into a patent. Of course, a large majority of almost every company, the value is tied up in trade secrets, but what Dragonchain has done, and what a lot of companies at a certain point, they need to trade those secrets away and get in their place these heavy instruments to block a competitor right out in the open, versus just trying to keep everything behind locked doors. So today I'm going to talk about these two first patents that have been granted. One pertains to Interchain, the other pertains to Dragon Den, and they're shown in red and blue, and I'll try to keep this brief and brisk for you. But these cover pages are where you can see the inventorship for each, the dates. What's interesting about one of these, I think it's the one on your left, is that it was granted 108 days after filing. So I think this is actually the fastest granted blockchain patent in US history.
And for people who haven't been through a patent process, what really is a patent, and why do we really care about them?
A patent, so you are, it's the government, and in fact the Constitution established a system where, in order to incentivize people to do invention and to reveal their inventions, teach it to the public, you get a monopoly. Normally monopolies are illegal, but you can get a monopoly, a lawfully authorized monopoly, in exchange for your good teaching to the public. So, and if you do a good job, you can get a really good patent. So that's kind of the deal.
Are patents like open source legal documents?
Yeah, you could say that. They're not self-enforcing. It's not illegal to, unlike say copyright. It's illegal to steal someone's movie or their song,
Right.
but it's not, and it's illegal to use their trademark. It's actually a crime. The FBI and the police care, but it's not illegal to infringe a patent. It's something you have to enforce yourself.
Huh.
And so that makes it a very kind of expensive, heavy artillery kind of a combat mode, and so they involve a lot more thinking things through than other kinds of intellectual property tools.
Cool. Thank you.
So these two were very carefully and strategically selected from a broad array of innovations at Dragonchain. So I'll move forward through this. This is really terribly dry material, I've got to believe, even for software people. There's syntax, and it's just, but I'll try to keep it brisk. And here is my quick self-portrait. I'm the guy whistling, pushing the wheelbarrow through hell, and for those of you who can't see, the devils are in the background of this Far Side cartoon. And one of them says to the other one, we're just not reaching that guy. But anyway, I'll come back to this guy. So the interchain related patent, which is called Distributed Ledger Interaction Systems and Methods, includes this for figure 1, and it has the middle of the 3 nodes. We're a little compressed here, but the middle rectangle represents the Dragonchain system, and the others on the outside might be, for example, public blockchains. One might be Neo, one might be Bitcoin.
Bitcoin,
Yeah.
Ethereum, Ethereum Classic,
Yeah.
and Binance now.
And Binance now. So this is kind of just a basic symbology that we begin with to try to bring the readers up to speed. And the readership of a patent is the public. We're trying to teach the public how to use the core technology of the business. So that's and it's kind of a daunting thought, and a very deliberate kind of a thing to do. All right, and this is for those of you who ever look at this patent, which is 10,135,607. That's patent number 10,135,607. We'll call that the 607 patent. Figure 6 has some key items of interest. This on node 170 has a series of blocks. Within the blocks there are elements. Everything is a lot of objects are shown with a dashed rectangle and numbers, and part of this is to facilitate translation into other languages, because you need to do that. Patents are a country-by-country element, so far we have issued U.S. patents, and but those can easily be expanded to other countries. And getting a little bit more toward the core of what this blockchain patent, the interchain related technology, we have figure 14, which has 4 steps. These don't necessarily correspond with what is in the claims. And so I'm going to show you really briefly how to read a patent like a patent attorney would, which means first you maybe glance briefly at the cover page, start to glance briefly at the figures, but really gray matter is soft and mushy. It doesn't last very long unless you're here and you're doing a 24-hour marathon. I don't know how you guys are holding it together. I had a nice night's sleep last night. But when you're reading a patent, I recommend going straight to what's most important while your mind is still at its best. And so it's important to be able to identify a thing called an independent claim. The things on the last pages of a patent are, they defined the metes and bounds of the invention. And so the independent, I'd like to call your attention in the lower right corner here, I have claim 2, which says the transistor-based distributed ledger interaction method of claim 1. So this is not an independent claim. It can't stand on its own. It's a slice of the pie. The pie is claim 1. And it's not the only independent claim, but it's one that doesn't refer to the others. And so you can forget about claim 2 for a while until you understand what claim 1 is about. So and the way to save your brain for the few independent claims if you're going to look at a patent. And this one has the way to read an independent claim is like this. You say, nothing is covered by this claim unless it has a transistor-based distributed ledger interaction method comprising. And then nothing is covered by this claim unless it's... So this is kind of a little mantra to assist lay people in going through and figuring out what this patent covers. Now you may think this is the province of lawyers, but this is exactly what a programmer, engineer, investor, executive should devote their energies to. If you want to know what's in a patent, never mind the abstract, never mind the title, go to the independent claims. So this one, if you get past the basic steps of recording and executing, there are 3 particular sub-steps, and they're indented in this. One of them is accepting an expenditure of a special purpose cryptographic utility token belonging to an entity who transmitted a request for an execution of said smart contract. See, it's a little dry already. You've got to work through it. It requires a certain fortitude and a certain freshness. But I want to call your attention to the fact that figure 14, the flowchart that most closely tracks that claim, doesn't have this expending a token. So this is relatively more summarized from a technology standpoint. If you can find the claim that the flowchart that corresponds most closely to the claim, you can maybe get to the heart even a little bit faster, at least in the case of figure 14. So after the accepting and the expenditure, we've got the iteratively monitoring one or more public nodes for one or more requester specified phenomena of interest. So this is a watcher, wherein said one or more requester specified phenomena of interest include first and second asset transfers from a requester specified digital wallet. So you're monitoring a wallet. This has to translate to mean something in your world. Am I making sense here?
Absolutely.
Okay, so there's something recognizable in the legalese. Next, and this is the last listed step, we're transmitting to one or more mining rig nodes a result of the transaction of said second smart contract, partly based on the cryptographic utility node data, and partly based on the distributed ledger destination being implemented. So we're sending things to mining rig nodes. So what does that tell us?
I'm sorry, I lost the context.
What the fact that mining rig nodes are part of what's happening here, they're a destination,
right,
is something that's going to be present in certain kinds of transactions.
Right.
So proof of work, right? There's
that
mining rig
that
nodes
would be for Bitcoin, sure.
signifies Bitcoin. So claim 1 has a meaningful limitation. It doesn't extend beyond things that are recorded on mining rig nodes. But if you're interchain, so you might have a non-proof of work blockchain public blockchain over here,
like Dragonchain, and it can go to the next one. I get it.
and then when you're recording the hash over elsewhere, then you're finally getting around to writing on a mining rig node.
So what you're saying is it's very specific, but in the same time, it's limited to the patent is for taking it from one chain and going to another mining rig chain.
Right, a mining.
Okay.
So a proof of work node is the destination recited here. You're not going to infringe this claim, the literal terms of this claim, until you're actually sending things out to a set of mining rig nodes, aka.
So if someone were transmitting data between two web servers, it's not a big deal. But to a mining rig,
Right.
that's something that is in Dragonchain's patent.
Right.
Got it.
And more particularly, claim 1 is limited to those kinds of proof of work contexts where, as I defer to what's recited here. What matters is what's in the claim, and you can read the claim. That's what I'm hoping people will take away from this. Okay, so then let's briefly touch on some of the salient points of the Dragon Den patent before we get before these things get too dull. So we'll jump straight to figure 11 in this case, where basically a trust-related metric can be seen in the case of the middle broad swooping curve, beginning back in 2017 when somebody started acquiring that trust. Over time, it increased. It appears to be logarithmic here, but we're on a logarithmic scale. So anyway, 161 is what I would call an early adopter in this middle curve. Then 2018, 2019, this entity is steadily gaining trust. At the end of 2019, it's got about 500, and this could be DDSS or
Dragon Days of Slumber.
Dragon Days of Slumber score, or other similar kinds of metrics that measure clout that can be used. Also in this graphic, we have in 2020, late 2020, is posited someone who was rapidly gaining trust, maybe because they were holding a ton of dragons or doing some other qualifying activity or circumstance that would cause them to accelerate quickly, but then they suddenly changed their trajectory. Maybe they sold off their most of their dragons, and they now gain trust at a slower rate. So those are kind of explaining to the readers of the patent the manner of a manner of escalation that is covered. Now, this brings me to an important point about patents. A patent shouldn't just cover the subject, activity, or product. It should also cover competitors. That's important. Okay, so these are other depictions, 18, 19, and 20, of 3 different participants in an ecosystem, where 18, what's shown in figure 18, is one entity over the course of several weeks, week 31 through 37, steadily gaining trust. In figure 19, we have, okay, so figure 18 might represent I'm gonna start mixing
Go for it.
fictional modalities here. Figure 18 represents Chancellor Palpatine. You remember who Chancellor Palpatine was? Okay, who's Chancellor Palpatine?
The Emperor in Star Wars.
Okay, now I screwed it up. This 18 is Chancellor Valorum. Do you remember who Chancellor Valorum is? He's the real deal, the nice guy, the one who was in place before the Sith Master snuck his way in and became the Emperor. Mm-hmm. So Chancellor Valorum, doing what he should in figure 18, he's a good guy, and he's doing what good guys do. Figure 19 is Emperor Palpatine. He starts off at going along like a normal person, but then suddenly, here at the beginning of week 36, he buys 1 billion dragons, and so he starts increasing his score dramatically. Similarly, figure 20 has a third participant in the marketplace, behaving like a good guy. Or maybe 19 is a good guy, but something happened where this person is now going to become a dominant player rapidly. But it isn't instantaneous. Under the Dragonchain system, in Dragon Den and similar kinds of contexts, the fastest a new entrant can grow isn't infinite. You can't just buy your way to the top. Figure 21 now demonstrates the shared power, where the Chancellor Palpatine is shown in the bottom, suddenly going from about 10% to about 85%. But these other participants, like Chancellor Valorum, are still hold a share, and so they are going to be in a position, I guess what you'd call it a whistleblower position, where if the checks in your L1 through L5 architecture are not passing what they're supposed to be checking, then at least there's always some chance that
there's a check and balance in there. There's always someone.
It is. Even though Chancellor Palpatine now wants to do all the work, trust me, I'll handle it. And Chancellor Valorum, maybe he's discredited to some degree, diluted, but he's still present, and that the risk that Chancellor Valorum may check in at some points and become a whistleblower is an ever-present systemic influence in the marketplace.
Yep.
In the ecosystem.
So if I could jump in for a second. So if you watched Joe's presentation on time earlier, this is the case where someone came in and bought 1 million time all at once, and let's just say they were $1 each. The Palpatine character would have to have a lot of funds and a lot of money to do that, whereas Valorum bought 1,000 and held those dragons, when we're now calling Dragon Days of Slumber Time, over that long period. So this is the legal description of how that works and how it's defensible, because we're the only ones allowed to do this and allowed to do this type of connectivity and interchain, which is really fascinating. So you're really unpacking this from a very different perspective because everybody's been looking at it from sort of the mining and technical perspective.
Mm-hmm. Mm-hmm.
Cool.
So in this earlier graphic, we had trust in Figure 11, we had trust growing as a function of years. Here in Figures 18 through 21, we're showing it growing over a factor of weeks during which a precipitous event happens. The detailed flowchart pertaining to the claim of interest, the most closely detailed flowchart in case you want to get online and study this a little more closely, is Figure 25. But of course, if you're going to try to understand the real meaning of the asset, you're going to look at the claims, and claim 16 is one of the independent claims. It's got steps of associating, allowing, applying, transmitting, accepting, and triggering. So that, that's actually something that, with some study, you could understand exactly
Sure.
what was covered by this patent. However, there's one other factor, lest you think that you're free to just step around what is within the boundaries of Claim 16. Please be advised that it's customary to prosecute outward. So you, in the initial stages of negotiation with a bureaucratic entity like the Patent Office, they'll give you a certain amount, a dinner plate of scope. But then as you negotiate, they can see clearly that you're entitled to more of a banquet level of ownership. So just because you study one patent, you better understand the whole portfolio.
Right.
If you're gonna try to imitate, which is, to a degree, imitating is allowed. Once a patent expires, it's allowed. If you can do it, if you can imitate but not be within the scope of the claims, that is allowed. But you've got to keep an eye on the whole portfolio. And I would like to express some words of praise to Dragonchain, because relative to some clients who trust me to carry their precious thing for them, Joe Rotes and the other folks at Dragonchain took a heavy interest in what I was doing, which from my perspective, it makes the job a bit harder on one level. I had to actually learn this stuff. People were looking over my shoulder, asking questions. That is exactly how you want to treat your Sherpa if you're going to go through a horrendous place like the Patent Office. Go, don't send them, go with them. So, but just because you have an instrument of war doesn't mean you have to use it. These things create order, they create appropriate prestige in the entryway to your office. It was suggested that I might want to comment on, briefly and broadly, on how attorneys look at blockchain developments. And basically, from the dawn of time, we've had a lot of unworthy proof of stake type evidence. Where instead of the rule of law, you had a person in charge. You had the rule of the king or whoever had authority, and it's all to the good to have the rule of law. Even the best of us, for the most part, would like to have the rule of law, and I think that blockchain is a valuable way to restore that. I'm hopeful that as we go forward, that blockchain can be a positive influence. It's a lot of change. It's a lot of work. Attorneys like to keep busy. These are blockchain creates powerful new tools and a certain level of accountability that is delightful. Okay, and then one final thought, a hot place with legal overtones. Here is a map of hell. It even looks like a patent drawing, does it not?
I defer to you.
All right, let's just take a moment then, and we're gonna visit the patent office. So this is uspto.gov. Clicking on patents. And I'm gonna do the advanced search.
So this is a website that's open to anybody to search.
Yeah. So it's a government maintained website, uspto.gov. It has patent searching capability, and I'm just gonna demonstrate that.
And it was clearly written in the 1990s.
Yes. So looking at assignee name of Dragonchain, I'm going to hit search. So those are the two patents, the 829 and the 607. And if you follow this, you can get a full-text searchable version of this patent. This one doesn't have drawings to it, so you'd have to click on the images, or you can download whole PDFs of the patents that include the figures at Google Patents or pat2pdf.org, public websites that let you obtain the PDF copy.
Perfect.
That's all I have. Are there questions that might have come in? Is that too much to hope for?
No, I
I
think
think
we're
you answered
good.
the one.
Yeah.
All right. Well, very good.
Awesome. Thank you so much for coming in.
Thank you,
for
Lauren.
sharing with us.
All right.
All right, we'll be back in a few minutes with the video of my interview with Paul DiMarzio from the Enterprise Ethereum Alliance. Happy Wednesday. I'm Lawrence Lerner with Dragonchain. I'm president of Dragonchain Consulting. We're joined today by Paul DiMarzio of the Enterprise Ethereum Alliance. We're super excited about that. Dragonchain has joined the Enterprise Ethereum Alliance to help build out coordination and collaboration among blockchain projects all over the world. Paul, welcome again. Thank you. Could you tell us a little bit about yourself and the Enterprise Ethereum Alliance?
Yeah, sure. So I'm Paul. Hi, welcome to my home office here. Coming to you from, well, I guess it's kind of sunny Connecticut today. So I've been a tech head almost my whole life, certainly my whole career. I've been at EEA just since the summer, so I think I started literally on August 1st. Prior to that, I worked at Digital Asset for a couple of years on their smart contract language. Prior to that, I was at IBM for 33 years. Long time, 3 decades. And my last assignment there, I had been working on their Fabric implementation. So, very, very long career. Super psyched to be at EEA. I'm still learning the ropes here after just 3 months, but it's been a fun place to work for sure.
Great. Well, very different cultures, approach to the world. Would love to get your perspective on that. And where is EEA going, and what are your thoughts there about, the mission of EEA?
Yeah, well, you certainly can't get much different from, IBM, even the DA, which had about 130 people at the time I joined. EEA has, like, I think me and Ron, not too many folks in it. I really like the freedom. I like the camaraderie you get in the small teams. There's really no corporate oversight to deal with. And what I like about the EEA is this is the first time in my career I've not worked on a product. Always worked on a product, so always had to say mine is the best. This is the best. Everybody else is a competitor. Now I can look at all of our members and what they're building, and have a very open view, right? So we've got maybe 5 or 6 different client implementations in the EEA, and I love them all, right? So they all have their strengths and weaknesses. It's really nice and refreshing to be able to not have to worry about the competitiveness and just focus on taking this ecosystem and pushing it forward. I really enjoy that a lot.
Cool. So you've got this ecosystem role, as you said. So what does it mean to be a community manager, especially for something like Ethereum, which arguably the whole blockchain community owes a large debt to for kicking things off?
Yeah, there's one thing I found out, right off in working with Ethereum here is there are a lot of stakeholders involved, and they're all very, very different, right? So you've got, folks that are building out the enterprise software. You've got the folks that are consuming it, and many of those are super large companies, especially the banks and the financials. And then you've got the vast ecosystem of just core Ethereum developers, and they all look at the world a little differently. They all have different wants and needs, and my role is to kind of really try to understand where everybody's coming from, and bring everybody together. So all towards the common goal of raising this ecosystem for everybody. Right, so everybody's got a different voice, a different stake, and I'm trying to align all that in this role. Cool.
So in that ecosystem, there's a lot of different working groups that the EEA has brought together. Can you give us an idea of how many? Give us some examples, and maybe even some of the use cases that those working groups have in play at the moment.
Okay. We probably should first really examine what we do in the first place, right? Because the working groups are an offset of that mission statement. And, the EEA it's a member-led industry organization. And what that means is that, the folks that are the stakeholders, in building stuff out and consuming stuff in Ethereum, found that there was a problem. So that everybody was building their own, everybody was building a vertical. And we were starting to see in Ethereum the same sort of fragmentation and siloing that you would get in the corporate world, with everybody owning their own databases, everybody owning their own infrastructure. So those groups got together and formed this alliance, which is really just a way for everybody to work together towards standardization and interoperability. It's a very I would call it a very consumer-oriented focus, right? What we do is we try to understand what do people really want to do, on Ethereum? And I'm not talking about, the core developers who already know, they love it, they're working on it every day. I'm talking about, the folks down the street. If you were to even mention Ethereum to them, they'd give you a blank stare. I do this all the time with my friends and my family. I say, I'm working for this Ethereum organization, and, they do that. And they say, you ever heard of blockchain? No. You ever heard of Bitcoin? Oh, yeah, we've heard of Bitcoin. Not because they use it, just because it's in the news, right? So we're trying to make Ethereum a household word by bringing that standardization and trust around to it. So, that's kind of what we're at. Now, in order to accomplish that mission, we form into these different teams, right? So we've got working groups, task forces, and special interest groups. And, the working groups are really where the heart of the real technical work gets done. And the EEA was focusing mainly on a client spec when I joined, and that's still kind of the case. So, if you're going to run an Ethereum node in the enterprise configuration, you want to run a client that has certain capabilities to it, and that working group focuses on that. What I've seen happen then is, as you want to start to focus in on certain problems within that space, we spin off these task forces, right? So we've got task forces running now on trusted off-chain computing, interoperability, so cross-chain interoperability is one. We've got another task force focusing on consensus algorithms and so on and so forth. And then we have the special interest groups, which are less formal, and they're generally focused on either a vertical or a topic, right? So we've got, say, a financial services special interest group. We've got a retail. We've got an insurance, and so on and so forth, and then topics like security. All told, I think we've got about 20 groups that are running right now. Yeah, it's quite a, even though the EEA, the people who work for the EEA are small, we've got over 200 members, and so there's a lot of folks involved, and we just keep herding those cats and moving them down the road and trying to make things work as best we can.
You've got a lot of reach and influence, and Dragonchain is super interested in all of those things around interoperability. I mean, that's one of the foundations of Dragonchain, and we hold 2 patents as an organization. One of them being on interoperability, and we obviously integrate with Ethereum and with other coins. And in terms of use cases, all of the things that you mentioned are important. I sit on the supply chain working group or a special interest group for EEA, and this morning we had a great presentation by Marley Gray from Microsoft on tokenization. So thank you very much for sponsoring and hosting that. So at the end of the day, as we talk about enterprise, and our prediction, my prediction has been 2020 was the year of enterprise, and 2020 is really where it's going to take off. What do you think, and what are others' thoughts about the ideal use case for enterprise, or what's going to be that fire starter?
That's a tough question to answer. I don't know that there's going to be one killer app like email or anything like that. Yeah. I think you're going to see just a lot of stuff taken off. Within the special interest groups of which you participate, we start to publish use case documents, right? So this year, the real estate and the telecom SIGs both published use case documents, which show the use of enterprise Ethereum in those spaces. And if I recall correctly, the real estate one was very much around tokenization, and it talks about using tokens to create fractional ownership of real estate, to bring liquidity to illiquid markets, things of that nature. The telecom one for me was a little harder to digest. It's the telecom's problems are very, if you're not in telecom, they're very obtuse. You're talking about all the inter-carrier protocols and things that have to get done. Talking about even the Internet of Things stuff, like if somebody's going to put a smart bolt deadlock on their front door and they're going to use their telecom provider to get it started. How do you make sure that you're not putting any malware down on there so the thing's going to pop open at any point in time? So these groups are building out these use case documents. So I think we're going to find certain use cases for every vertical are going to come out and kind of start to lead the way. It's really hard to say which one's going to kill. I think they're all going to kill. I think it's a great environment for just about any vertical.
Yep. So as we head into the end of the year and look forward to 2020 and 2021, what are some of your predictions? What do you think the major trends that we're going to see over the next 18 months?
Well, the thing that I'm personally really stoked about is this alliance that we've made with the Ethereum Foundation. It was announced earlier in the year. We've been working towards it all year. It's been one of the main things I've been working on since I've been here. And as you can see, I was at DevCon 5. We had some really super packed meetings about it there, and in fact had our first call just yesterday. And what this alliance is going to do is it's going to start to move a lot of the work we do on enterprise out of private chains, private permission networks into the mainnet. Right now, you could still run a private permission chain on the mainnet. You could still use the technology there and let everybody. If you don't want to participate, don't bother. If you want to use the mainnet as it's used today, power to you. We're not going to try to interrupt that. But what we're going to try to do is see if we could bring those elements that we've been doing so far in private, to work on the public Ethereum network. And there's so much buzz around this thing. And when I first started getting involved, I thought we were going to get shot out of the room and and booed off stage and all that. But the Ethereum communities, I think they're starting to recognize that enterprises really do want to start working on the public chain, and they need things that aren't there, right? So we need to bring those things in as options for those folks who want to use them, and that's what this partnership's going to do. So we just started this thing yesterday. I think we had about 150 people on the call. It's probably one of our largest calls ever.
Wow.
Yeah, and a lot of them were from outside. So I think this is just going to explode. And my colleague John Wolpert likes to call the mainnet the magic bus. That's his term for it. And I think we're going to see this magic bus take off and fly.
Fantastic. Well, Paul, thanks so much for spending time with us today. We look forward to following up in a couple of months and see how things have continued to progress. And we can talk maybe in more detail about our partnership. Hey, have a great rest of your day.
My pleasure. Thanks for having me.
Cheers.
Hi, I'm Dean Shelton, Director of Engineering at Dragonchain. I wanted to show you how you can use smart contracts on Dragonchain to get your business logic onto a blockchain. It's actually pretty straightforward. Let's just jump in and do it. I have a chain here that I built out. It's a level 1 Dragonchain. I called it Demo or Die. And we're going to put our own business logic on here that's going to read from a private Ethereum network, pull the data into a contract, do some business logic, and then push it back out to the private Ethereum network. So in and out with our business logic in between, pure blockchain. And we can do it with Docker. I have here on my screen, this is a TypeScript Node.js contract, but really you could write this in whatever language you want. You could write it in a single line of POSIX shell, probably. JavaScript's a little verbose, but this will get the job done. You can see it pulls in a found Ethereum transaction, and this will just be an array of numbers, so it'll end up looking sort of like this, 1, 2, 3, and it'll add these numbers together using an array reduce, and then it should output the result of the sum of this array. And that could be an array of any 3 numbers. I have a script here that's going to generate that on this private Ethereum network. You can see 3 numbers randomly between 1 and 9, and it's going to send them to this address with no value, no ETH, but just as a data transaction. So I have a private Ethereum network already set up. Let's just SSH into it. This private Ethereum node. This is just on an EC2. It's running Geth. And you can see this is the Geth node just mining away, doing its magic, throwing garbage out into the universe. That's what's happening. So we want to generate some traffic on this network and then have our Dragonchain pick it up, do the business logic, and send it back out. That's what this demo is going to be about. So how do we get our JavaScript or POSIX shell or Golang or Ruby or whatever onto a Dragonchain? What's that process look like? Well, there's a couple options for you. You could use the user interface at console.dragonchain.com. I'm on our staging site, but you could just click on create contract, select custom, and give it all the details for your Docker container. And once you push create contract, it'll just pull your Docker container in and run it. But let's do it from scratch here. This is the example interchain project that I'm in, and we're going to build and push this Docker container. Docker build dot, and I'm going to call it something. I'm going to push it to my own repository on Docker Hub. I'm going to call it Booyah. So I'm going to just build this, and that should go. Okay, and now I'm going to push it up. Okay, Booyah. All right, so now my Docker container is sitting there on Docker Hub, ready to be used on a Dragonchain. So what do we do to actually get that onto the Dragonchain? Well, you could use the UI right here, or you could use DCTL, the Dragonchain command line tool, to add your contract. And I like to do it because it's really turnkey and easy. But you can see I'm already connected. If I say DCTL status, I have my keys plugged in, and I'm talking to my Dragonchain with an ID of this. This is the demo or die chain. So let's add our contract here. So I'm going to just say DCTL contract, create, and I'm going to call it business logic. And I have to give it the Docker URL, which, let me make this a little bit bigger here. So this is at docker.io/Dean Shelton 913. Booyah. Oop, I spell it right. Booyah. Yeah, it was booyah. Booyah. Right, that was it. Yeah, that was it. Okay, so here, booyah, latest. And then we're going to tell it how to run it. This is a Node.js application, and it runs at app dist index.js. This is just the start command for whatever container you use. And that's pretty much it. That's all you need to give it. And this should create my contract. You can see the business logic contract's being created. It's pending right now. So if you were to go to the UI, you could actually probably see it there getting built out. Let's go to the chain details page and refresh. And there it is. Boom. Okay. So it's active. It's actually already ready. So cool. So now we have our business logic on the blockchain from a Docker container. That was pretty straightforward. Now we just have to feed it information from the Ethereum network and then allow it to publish that information back out. And Dragonchain has two really easy contracts pre-built to help you do this. There's a watcher container and there's a publisher. And you can go through the contract creation process here and create the watcher. Really straightforward. Just give it a name. Doesn't really matter what it is. Tell it how often you want it to run. Tell it what address that you want it to watch. In this case, we're going to be watching this address that I'm going to generate traffic on, which I hold the private keys to. And yeah, we can fill all that stuff out here. Or you could just use the DCTL command, which is really easy. So I'm going to do that. Create the watcher, and out it goes. And the last piece is to build a publisher. And you can also find that in the Ethereum publisher contracts. You can even tell it what private network you want to talk to. Mainnet, Robston, Custom, Morden. I mean, this means you could use a contract to read from one Ethereum chain and actually publish to a different entire Ethereum blockchain. Or if you wanted to make a publisher for a different network, you could even publish to Bitcoin or Neo. So that's kind of cool. Let's just shortcut it, and we're going to use DCTL to create the publisher. It just is the Dragonchain publisher container with all the information that it needs to talk to the private node, which is just this. So here we go. Copy this, and I'm going to create that. Okay, so now we have 3 contracts out on my Dragonchain, and we're going to check them out. Let's see if they've loaded yet. So we've got 2. The third one should be installing right now. Okay, one more. All right, so after we get these things up and on our chain, we're going to tail the logs. Let's see if they actually get created. So, show me potato salad. All right, Okay, there it is. The publisher. Here we go. Okay, cool. So we have a watcher, business logic, and a publisher. It goes in that order. We watch things on a private network here, and it's going to feed information to our business logic, and that's going to go to the publisher, which sends it back out to the blockchain. Let's set up some watchers and tail these logs so we can actually see it happen in real time. We have the blockchain happening right here. This is just it's a private Ethereum. So we're going to create a pipe to our contract. So let's just watch this thing happening. This is I forgot this. This is the watcher contract. Cool. So you can see it just running here. That's watching the Ethereum blockchain happen over here. I'm going to grep the output here so we don't see that verbose output. I can just do grep when it finds something and show the 10 lines after that. Okay, so we have that grep running. Now we're going to tail the logs for our business contract. And I'm going to clear this thing out, and we can link it to our contract here. This is Business Logic's contract ID. Cool, okay, no output yet, that's good. It hasn't been triggered. So lastly, we're going to tail the logs of the publisher over here. So, okay, and you could also look at these logs in the Dragonchain console. They're available by just clicking the log button and refreshing that log stream. But I like to do it on command line because, I don't know, just more developer friendly, I suppose. So now all there is to do really is to submit traffic on the network with this create transaction endpoint. And we should see that go out to the network. Let's do that now. So I'm going to run that script. You can see we created a transaction with the numbers 2, 3, and 6. And the Ethereum node takes some time to do the block. But once it creates a block, it goes all the way through. And this log here is the publisher transaction. So you can see it actually published out to the Ethereum network, which in our case was that private node here, this address. And this is the transaction hash. So let's see what that looks like. I have a block explorer for that private Ethereum node just sitting right next door to it. And if we look at its transaction, it published this data, which is, if we go here and translate it from hexadecimal to UTF-8, you can see that we linked the Ethereum input hash here. So this is actually a hash on that same network with the new output hash, which we just looked up. And it has 2, 3, and 6 outputting 11. So that's our business logic exposing just what we want on the private Ethereum network. Input, output, private, nothing's public, and out it goes. At this point, this transaction has now been recorded on Dragonchain, so it's going through the 5 levels of consensus, and everything that we've just done is ledgered on the blockchain. So a pure blockchain solution that interchains private Ethereum. And you could really do this with anything. I guess that's it. Thanks for watching. Yeah, happy coding.
Welcome. I'm Danny Leckie with Dragonchain. Today we're going to walk through a command line tool that we call
Hi, I'm Dean Shelton, Director of Engineering at Dragonchain.
Welcome. I'm Danny Leckie with Dragonchain. Today we're going to walk through a command line tool that we call the DCTL tool, which will help us get started within Dragonchain in a really fast, expedited, accelerated way. And so what we're going to go ahead and do today is set up a level 1 private node on Dragonchain Cloud on our BAS service. We're going to go ahead and install the DCTL tool, create a transaction type, create our first transaction, and then query those transactions. And that will set us going on Dragonchain on a level 1 node so we can validate and verify transactions. So let's go ahead and get started. You can go to dragonchain.com and click the Get Started button to provision a new account into the Dragonchain. Let's go ahead and enter in our name, our company, and an email address. And let's go ahead and enter in a password and create the account. Now, when it sends when you click the create account, it's going to go ahead and send a verification code over to the email address that you entered. Let's go ahead and open up that verification address, copy it over, and then paste it into the box itself. And we can go ahead and confirm the account. This is going to bring us into the Getting Started page of Dragonchain. There's a couple of different options that you have for creating a chain. You can create a managed chain. This would be Dragonchain hosting the service itself in a managed software as a service or a blockchain as a service type model. You could also register an unmanaged chain if you wanted to host something on-premise, if you're running Kubernetes and wanted to run Dragonchain in your own private cloud or your on-premise solutions. Today what we're going to go ahead and do is the cloud solution. So let's go ahead and click Start Developer Plan. And when you click that, it brings us into a page where we can go ahead and create a chain. Now we're going to go ahead and name a chain. In this case, I'm just going to call it My Chain. And we'll go ahead and click the Create Manage L1 Chain. And what this does is it returns back a set of API keys and how we can connect into it. We really simplified this down by making a downloadable file, so we can go ahead and just click Download, and we can go ahead and save that file. We're going to use these keys later on to be able to configure the DCTL tool. Let's go ahead and close this box down. And we can see that the chain itself is initializing. It normally takes about 10 minutes for an L1 chain to initialize for the first time. In the meantime, let's go ahead and get started with the DCTL tool. So if we go to the Dragonchain repository on GitHub, that's github.com/Dragonchain, you can see a number of different projects or repositories that we have in here. And here's the DCTL toolkit itself. If we click on DCTL, we can take a look at the README file, and we can see the system requirements for setting up Dragonchain. In this case, it requires Node and NPM. So let's go ahead and open up a command prompt, and on the command prompt, we're going to go ahead and just see if Node is installed. So we're going to type node -v, and that should return back a version. In this case, it's 10.15. And we also need npm, so let's go ahead and type npm -v. And in this case, it returned back 6.4.1. And so both Node and npm are installed on my box. So if you didn't have Node or npm installed, you could go to nodejs.org and install it. The package right here, this 12.11.1 is a current package. You can install it both for Windows, Macs, or get the source code. This package installs both npm and Node.js, so there's only a single package to install. And then once it's available, you're ready to install the DCTL tool. Now, it's as simple as just typing in npm install -g DCTL, and that will go ahead and install the package. So let's go ahead and do that. npm install -g DCTL, and this pulls the package from npm. Should be finishing up in just a couple seconds, and there we go. It is done, and it took just 5.5 seconds to download the package, and it's all set. Now, if I type DCTL, I should get some responses back, and I can see all the commands here. If I type DCTL -V, it returns back the version. Now, if I go ahead and do DCTL -status, it'll tell me that it's missing a configuration file. That's because I haven't loaded any of those API keys, those HMAC keys that we downloaded previously. So let's go ahead and get started with loading up the keys so we can connect into our L1 chain. And so to do that, let's go ahead and type DCTL, and there's a command called creds. Creds will allow us to add a Dragonchain. So if I type DCTL creds -add /add, it will give us a set of commands to be able to enter. Let's go ahead and just type help to get the syntax of it. So in this case, what we're going to go ahead and do is type DCTL cred add. We want to go ahead and type in the Dragonchain ID. So to do that, let's go ahead and open up this file. We're going to go ahead and take the Dragonchain ID, which was in the square brackets from that master's file. We're going to go ahead and click that, and we're going to also use a endpoint, the endpoint API. So let's go ahead and grab that, starting at the HTTPS all the way to the api.dragonchain.com. And so let's go ahead and do space -e and we're going to go ahead and paste in the api.dragonchain.com URL. And it's going to prompt us for our HMAC key ID. So we're going to go ahead and pull that from the file itself. That's the shorter key ID, and we're going to go ahead and copy that, paste that into the key ID, and let's go ahead and copy the auth key from the master file and paste that in there. And it's now set up the credentials files. And so now if I do a DCTL space status, you can now see that it's connecting into my L1 chain with the ID that starts with 27. And so now I'm able to actually query the key. If I wanted to take a look at more at the creds, I could do something like DCTL K for creds and do an LS to take a look at all the chains that I have configured within my credential files. I only have one chain right now, which is the default chain starting with 27. Before I can create a transaction on my chain, I need to create a transaction type. So let's go ahead and do that. So in this case, let's just go ahead and type DCTL, and there's a command called TT, or transaction type. And transaction type lets me do a command called create. So DCTL TT create, and in this case, what I'm going to do is call it Super Happy Dragon Lucky SHDL. And that's going to go ahead and create my first transaction type on my chain. If I did a DCTL transaction type LS, it'll go ahead and list all the transaction types on there. There's only one transaction type, but I could create other different types of transactions. So let's just go ahead and create another type of transaction. Let's just call this one JoJo. And so now I have two transaction types on my chain. If I do a DCTL TT space LS, I can see that there is a JoJo transaction type and an SHDL transaction type. Now, let's go ahead and create our first transaction. To do that, we're going to go ahead and type DCTL, and there is a command called transaction. And we can do a transaction create. And to do a transaction create, it asks for a number of different commands. So in this case, it's going to ask for a transaction type. We're going to call this one Super Happy Dragon Lucky. We're going to call the payload. In this case, let's go ahead and do a curly bracket. And because I'm in Windows, I need to escape my quotes. But this is just a key value pair. So let's do escape quote, and I'll just do name. And let's go ahead and escape that. Put a colon in there. And in this case, let's go ahead and escape that colon. And my name is Danny. We'll go ahead and escape that and colon and wrap it up with a curly bracket. And let's give it a tag actually too. So let's give it a tag of name. A first name, and now let's go ahead and hit enter, and I can see that it gave me a 201, that the status was successful, and then I got a transaction ID back. So now if I wanted to go ahead and take a look at that transaction, I could do a DCTL and I could do a DCTL transaction, and there's a transaction get, and I could do a get and the actual transaction number or ID that I had from down up above, paste it in there, and it returns back the header information with the tags that I put in there of first name. It gives me the payload of my name being Danny and the proof that that transaction took place and that the transaction was successful. Now, if I wanted to create another transaction, I could go ahead and create a transaction. In this case, let's go ahead and call this one a JoJo type. And since it's a JoJo type, let's just call the name Joe itself. And went ahead and created a JoJo type of transaction called with the name of Joe. So we can go ahead and create another transaction type in the JoJo type, and we can call that one Brandon, and press enter, and it also returns back another transaction type for me. So now if I wanted to go ahead and query those transactions, we can go ahead and do DCTL, and we can do DCTL transaction type, and there's a query command. Query commands require a transaction type, so in this case we're going to go ahead and do JoJo, and the query that we're going to do is just first name, right? The tag that we entered in before. And what's going to happen is it's returning back the JoJo transaction type with the payload of Joe, and it returned back the transaction type of the payload for Brandon. But you can see that it did not return the transaction payload for Danny because it was a different transaction type that we called Super Happy Dragon Lucky, SHDL. So in that case, it would not show up in this case. But if we change the query type for the transaction type to Super Happy Dragon Lucky, we'll go ahead and be able to see the one transaction that was named Danny in that case. So there's a series of different other types of commands that you can use on SDLC. DCTL. On DCTL, you can see a number of different commands. There's the interchain command, where we can connect in with both Bitcoin and Ethereum. You could also query things like blocks, where multiple transactions combine into a block, and be able to query those specifically. Next week or in the future, what we're going to go ahead and do is walk through adding a smart contract. We allow you to take a Docker file and upload that to Dragonchain as a smart contract and use it. There's no need to learn Solidity or anything else. It's just ready to go. So we look forward to walking you through the smart contract piece. And until then, good luck and happy blockchaining.
Hi, hello everybody. It's a little past 8 o'clock here Pacific time, and we were going to have this earlier in the schedule, but we threw it in last minute. Basically, it's the Dragon Factor presentation, kind of rolling out what the app is going to be like. We have the app in development, it's working. It's not, we don't have all the styling done on it yet though. So we'll probably have demos of that coming weeks after this. So one way or another, Dragon Factor is a decentralized identity platform focused on privacy and focused on making it possible for a user to manage their own identity and factors of their identity and other data related. So what to kind of go over, and apologies, these graphics are a little bit small because of the way they fit on the screen, but go over the actual roles of the different people or entities that would be involved in this process. So you have a user, right? That would be an actual person. It could be an organization, it could be an IoT device, but we'll call it a user. That in the simplest case, and the order of this doesn't have to be as it is here. It could be in an entirely different order, but let's say that the user knows they need to have some factors in order to prove their identity, their age, their nationality, something, and they have either a driver's license or a passport, right? So they, through the app, scan the driver's license, they take a selfie, they do the things that you would typically do. A lot of people, you've done this many times, right? And they pass it up to an identity provider. The identity provider could be the company or website or organization that wants to use their ID, their identity, that wants to know who they are. But it could be a fully third-party independent. And in the Dragon Factor system, whoever is acting as an identity provider basically takes that document, in this case a driver's license or passport, and breaks it up into a number of unique factors. And we'll get into some of those in a minute. So they basically send their document in. The identity provider sends back separate factors that are to whatever granularity makes sense, because different documents will have different information on them. But as an example, some of the factors would be driver's license number, driver's license issuer, what state it is in, the user's full name, the user's first name, the user's last name, the date of birth, the birthday without the year, right? The fact that this person is over 14, over 18, over 21, over 25, over 65. And you could have anything else that would make sense legally, like say over 25 is in there because males to be able to rent a car have to be 25. Things like that. The address, the city, the state, the residency, the gender, the height, the weight, the eye color, things like this. And the point is, though, that each of these factors is completely independent of the others, so that the user can share them independently. They don't have to share everything on that document. They can pick and choose. Next, you have the role of the service provider. This would be a website or a bank, and an identity consumer. That is, the actual entity that needs the identity. So in this case, the user goes to this website or this bank or whatever it is and says, I want an account. I want some services. So the service provider says, I need this set of factors. I either need, here are some required ones, here are some optional ones. They could do something more complex and say that I could use any 3 of these, any 10 of these, or they could say something where they put scores on all the factors and tell you have to get over a score of 100, and then we'll let you in with a certain type of account. So the user can then decide if they are comfortable sharing those required factors with the service provider, and potentially saying, okay, well, I'm not going to give you that, but I'll give you this, or maybe I give you my birthday signed by 2 different identity providers, so that you could have 2 factors of the same thing and share them that way for a little more value. So in this case, the service provider wanted, or the user accepted and said, yes, I will give you my first name, the fact that I am over 18, and what state I live in. So something like this would be enough to get through a lot of typical websites. It's enough for some websites to do business with you, to know you're over 18, to know that you are in a U.S. state, and then to know your first name so they can put it on a website when they're talking to you, or for support, right? And so you provide that to the service provider. The service provider then holds that as a registration, and they know that you've had that from then on. So anytime the user comes back in, they don't have to provide username, password. They can sign a random challenge and prove to the service provider that they are the user that controls the keys, that has proven the factors that are needed for an account. Right, so a login is then something that your browser or your phone can do automatically. And in cases when you're going to make a purchase, or when something is of a higher sensitivity, that the system can challenge them again for another signature. So that being the architecture of Dragon Factor, and there's a lot more to it than that, in the way that we do some of the signings and implementations. this is the set of mock-ups for the mobile app. And like I said, most all of the functionality is already built on mobile, and we're just now going through we're going to prioritize to clean it up and make it pretty. So some of this might change, but this is generally it, that you open up the account and you can either generate an identity or you can recover an existing identity that you created on a different device. So let's say you're going to create an identity. You give it a name so you can track it. We will have a way to do a backup, obviously. That's not in this workflow here, but one way or another, once you have your identity generated, and that amounts to creating a key pair, but you don't have to know anything about that, and registering it on chain so that you can prove that it existed for rolling over the keys and things like that, and for adding new devices to that identity. So after you do that, you need to add factors, and theoretically you could go to a website that asks for factors first, and it would direct you to which ones you need. But in this case, we're showing 3 here that are instant factors. That is, that you can self-certify. You can prove that you own your Twitter account to the system. You can prove that you own your email. You can prove that you own your phone to the system. You don't have to go to a third-party provider. And all of these are very valuable because someone could accept the factor for your email and not have to have an infrastructure to send you an email to check. It knows, okay, I know that's your email because someone that I trust has already checked it for me. Same with phone, same with Twitter, for that matter. So in this, we're doing an email factor. You enter your email, just like everybody's done this. You go to your inbox, you enter the confirmation, the factor is added, and now it's in your account on your phone. It's not on chain because you control it. Now, later you will be able to put it in different places. There would be cloud options. There would be like say storage or Ziacoin, encrypted, decentralized storage systems, things like that. And then potentially also other devices that you own. So you could store them multiple places, and that's very much the intent, where Dragon Factor would not hold them for you on purpose. So you can see your factors. They would be organized by categories, financial, social, things like that, and it would show you some of the key info. You'd have the ability to see other devices, to sign stuff. There's a human factor that would be coming as well. Then we have, and look, Bitcoin address, Ethereum address, things like that also are other factors that you can self-certify. And here's the Twitter one, showing the exact same thing. You log into Twitter, you get a Twitter factor. You can now prove to anyone that you own that Twitter account. You have your sets of factors building. Now you have a physical address. You would basically have a way to prove it either by passport, driver's license, a bank statement, or utility statement, whatever the identity provider allows. And we know that we will have at least one identity provider coming out the gate. We think we will have 2, and there are a few others that we're looking at as well to help out. So, and some of them will come with cost, and we have to figure out if we can cover the cost, if it's something that the identity provider covers the initial cost, but they take payment when the factors are used. There are a bunch of different models that we're looking at for this. The important, I think the most important one is the driver's license and passport one, because it's the one that we can get the most information that is of most real-world value. That, if you have your driver's license or passport info in there, you could theoretically take it in anywhere and show them, I can prove to you that I have a driver's license issued by Washington State, and I live in Bellevue, and whatever. So a bunch of really neat stuff there. We will try to get a demo out in the coming weeks as well, whether it's pretty or not, but just so you can see the functional use of the system. And like a lot of you have known, Dragon Factor has been in place for almost 2 years now, and yet we've not put a front end on it. We haven't made it user friendly until very recently. So this is pretty key to a lot of different things we're looking at and working on, and there's some real value in having this capability built into our systems. We're going to make sure that this is integrated into Eternal and into Den, in particular with Den, because we want to sign everything. You know, we want the user to be signing the actual replies and posts transparently, you know, behind the scenes, provably, where you can say, it's like, was that really Joe that said that? And you'd be able to actually look at the data and prove to yourself that I signed something with the key that everybody knows is mine. So anyway, so that's the end of this presentation. I think I'm going to go back and check with the devs. We have to run until at least 9:20 or 9:30 to get to the 24-hour point. So I'm going to make sure what we're going to do to start that last demo, whether we're going to start it before and then let the other run out, or we're going to run the entire thing out and then start the last demo. So we'll let you know really soon. Be right back. Hello, it's a little past 9 Pacific time, and we're going to do a quick update. We are at 244 million transactions since we started, and we are averaging around 2,600 right now. The current rate is 3,500 per second, and we have the last demo coming up. I think we're gonna try to start it around quarter after 9. Depends on how long all the prep takes to get started. So I'll talk to the devs, and we'll be back sometime around 9:15. Hello, everyone. So we're back again, and we want to talk about the demo itself, and then also about this last peak performance demo, which should be starting pretty soon here.
The spike.
And we're at 246.6 million transactions since we started.
246 million since 9 a.m. yesterday.
And averaging somewhere between 27 and 2,900 when I was doing the calculations through the night.
Our goal
in
was
total.
to maintain 2,000 transactions a second for 24 hours, and we've exceeded that. So like pretty consistently. It would be interesting to grab the metrics over the entire, just the average over the entire span. We have hourly averages here,
Right.
but I'm pretty confident we've never dropped below 2K for this whole time. That's pretty impressive.
I was doing it through the night for the totals, and it was always. In fact, it was higher earlier in the night.
Ooh.
So
All
we're
right.
at 12,000
So
right now.
right now we're ramping up the load on DragonNet. So this is more worker nodes slamming Dragon chains with data, and this data is, fake usernames and addresses and like customer data that you could have in any sort of customer application. This isn't just like hello world or the number 1 or something. We're actually sending payloads that an actual application might send. So this is pretty representative of what DragonNet's capable of. So that last spike was 12,000, which was a lot. 12,000 transactions in a second. So.
And how many nodes? They added nodes for this peak test.
Yeah, we have 30 on standby, so we'll be utilizing them as necessary, and it'll just start picking things up. It's this multi-threaded process that just starts slamming, and its goal is to scale up, as high as we can get it. We're at 15? Yeah, 15,142 transactions a second right there. I'm nervous. I mean, I'm sure it's fun. This is fun. Everyone does this to their apps.
It's like some SpaceX stuff right now.
I mean, yeah, it's a lot. It's already sort of dwarfing the 4K, 5K spikes we've had there. So every 60 seconds we should see this update. Man.
And we weren't sure how long it would take to get into the system, so we were like,
Yeah,
well,
we've just slammed these broadcast processors full of information. So this is impressive. Here goes in 3, 2, 1. Okay. Whew. So the way that this works is the web servers on chain are accepting transactions as fast as they can, and they're loading them up in their message queues, and then they're grabbing as many messages as they can. 10,000 messages at a time, I think, and putting them in a block, and then hashing and signing those, and then putting that into a broadcast queue. Then it is being sent up to the network to get broadcast out to the other nodes for verification. So there's that big process of all these complex things are sort of happening in one go, and there's a lot of information flowing through DragonNet right now. So this is probably going to be the most. This is definitely the most we've pushed through the system. So this is a lot. So if you have level 2s, 3s, 4s right now in DragonNet, you're probably noticing a lot. Okay, it updated. Yeah, it's coming down probably because it grabbed the first ginormous chunk after we were waiting to push the button, and it was intaking, and we pushed it. So now it's gonna sort of level off as it goes. So we'll see how much it can take. That's impressive. 14K. Whew. 15. It was 15K for a spike.
mhm.
I mean, this just represents burst traffic you could have in a network. So,
Right.
Black Friday sales or something going on, you could just, DragonNet can handle that. And it's pretty impressive.
It's interesting.
Yeah.
Right. And we found we found some things that could be optimized that haven't been optimized I heard the guys talking.
Sure.
About
Mhm.
what was keeping keeping some of the numbers down. for the
250
staging. Oh, 250 million. All right.
250
yeah, not
million.
right. Okay.
250 million transactions since 9 a.m. Called it.
Call it.
Yeah, dude.
Basket.
Wow. Yikes. So that's impressive. I don't know what to say. I'm impressed with the tech.
Oh yeah. This is crazy. So, and how many nodes? There were more level 2 nodes added in the past few days. I
Oh yeah,
believe.
it seems like people have caught on that we're sending transactions through DragonNet, so there are other nodes spinning up all over the place. We've got more level 2s in the network than before we started. People are wondering how to spin up their own Dragon chains. We have a script online that you can download, and pretty much a one-button install to run your own level 2 Dragon chain and start receiving some of these level 1 transactions to verify. People are running them in little $10 linodes. You can run them for like $10 a month or something. Pretty lightweight. I've actually even seen some people running these on ARM processors like Raspberry Pis. So if you have the technical expertise to throw one of those together, that's a great option. But yeah, this is impressive. So I bet it's probably gonna level off there around the 10, 12 level, and then I don't know, maybe we can, if we add more nodes, we could slam it or pause the broadcast processors and let them intake. The thing is, the web server is taking in as much as it can, but if you pause the broadcast processing and just let the queue fill up on these chains, they'll be able to burst. So in scenarios where you have some Dragon chain has maybe like 30 web servers, they've scaled up to a ridiculous size so they can take all this stuff, and you're actually pumping in the network. Like DragonNet handles it no problem. So like the level 2s sort of scale out. As we see like humans get involved, they see what's happening, and then the network itself sort of reacts to it, and you get this this growth in the network that can handle the load. So it's this natural load balancing, which is pretty interesting.
We need to hear from them if they're trying to push it more. Do you know? Okay, I want to find out.
Okay. Sweet. What would be cool? Do we have any AMAs going on?
We don't have any. I think we were exhausted of the questions. I think almost.
Oh,
was. I think.
okay.
There are probably some new ones.
All the questions have been asked.
Oh, okay. Here's something we can go over. As of 8:30 this morning, 92,154 total level 1 blocks, and
Oh yeah.
of course now it's 250 million transactions. Let's see here for interchain. Total 199 interchain transactions over that 24-hour period.
We've hit 200 for sure now.
Yeah.
Interchain. That's
Yeah.
ETH Classic, Bitcoin, Binance, and Ethereum. Like all of those networks have received level 5 transactions during this time. About 200 of them in total. So that means though that for the low cost of submitting transactions on DragonNet, you actually get all of the hash power of those other networks. We've gone to 200 of them already, and we can do it less frequently, save a lot of money. So you don't have to spend all that money going to Ethereum or going to Bitcoin and paying all those fees, because DragonNet has nodes that pay them for you, and you just have to pay the fees within DragonNet. Much smaller, especially if you have a lot of time. So if you have if you hold Dragon and you keep it in your account for long enough, you can apply that time to your Dragon chain and lower your transaction fees. So these fees are incredibly low for the comparatively. There's no reason to go straight to Bitcoin if you can do that through DragonNet.
Right. Yeah, because they're aggregated. Do you know? I wonder how many blocks are in each of those Bitcoin. Because the Bitcoin ones would tend to get a lot.
Huge, yeah, because we go to Bitcoin less frequently because of its transaction fees. So every 2 hours, we call it the train leaves the station at every 2 hours or so. So during that time, we aggregate blocks in DragonNet who have gone through the levels 1 through 4, and they get sort of queued up in that level 5, ready to go to Bitcoin. So how many have gone in that last block? That would be an interesting number, but I bet they're fairly large. And we take their, the hash of those. We actually publish that as a data field, but we can figure that out. I mean, let's see, we have 30. We had 10 nodes running, 10,000 transactions per 5-second block, and then I guess all of those go all the way up through the level 4s. So,
Right.
And then actually for Bitcoin specifically, for the 2-hour duration, you have a 1 in 4 chance of getting on a Bitcoin node, so you have to factor that into your math. But we could run the numbers and figure out what, how many transactions on average went to Bitcoin versus Ethereum versus ETH Classic based on probabilities of selection in DragonNet. But I mean, the real moral of the story is that you don't have to go directly to these networks and pay those fees. You can use DragonNet and get all of the data security of the public networks just using Dragonchain.
Right, and that's important. And we should also say that these are completely, these are not transactions like in Visa that would still take days to reconcile. These are completed, done, signed transactions. So, or blocks. So, it's interesting.
Oh yeah, they're hashed, signed, and sent all the way through the network. Well, we thought for a while on how we're trying to figure out which number to track. We could track the intake of every Dragonchain level 1 in the network, and that would be one number that might be interesting. Or we could track the number of transactions that actually go through DragonNet. We opted for that one. That number is not how many transactions we've accepted. That number is actually higher, faster. We can bring more things in because we have to hash and sign those blocks and send them to the broadcast processor and go through DragonNet. But to be able to pull these type of numbers through the network is pretty impressive, because it's such a short period of time, and we had 10 nodes for that time.
And I asked them why yesterday staging was different, right? And we have unmanaged nodes in production. Staging, everything was in
we have
local. So
we have a staging DragonNet for testing stuff and new experimental features and stuff. And there's far fewer nodes there. There's less latency. There's not public nodes. So yeah, there's definitely more latency in production. So this is all expected. It's performing really well.
Yep. All right. So, and it is almost 9. I think if we run to 9:30, we're probably solid, right?
Yeah.
Because I don't know when we started. We started sometime between 9:20 and 9:30.
I'm sure we keep this going, and
Let's do it again, right now.
Oh man.
48 hours. 96?
Oh man, I'm gonna go to sleep.
You want to go to sleep?
No, Brandon wants to go to sleep. We should let Brandon go to sleep. Another 24 hours to get that coffee. Let's do it. All right. Well, what would be interesting? We'll try to see what if we could slam these any harder before we close this thing down. But being able to maintain that 5 to 12K, that's pretty impressive, even for this duration for a blockchain network.
Mm-hmm.
I've never seen any demonstration by a blockchain that shows that.
Right. Even the average is coming up.
Yep.
That's awesome. 255 million.
So
Crazy.
if you're interested in running your own Dragonchain node, if you want to get in on the network, you can go to our open source GitHub project, Dragonchain. It's on github.com/Dragonchain. You'll see links to the documentation to set up your own line node if you want to run your own. Or if you're interested in running in our managed service, you can go to console.dragonchain.com and sign up for a node there. I would encourage anyone to join up in the Slack channels or in Telegram. If you're interested in joining up with us here at Dragonchain by running your own node, we're more than welcome to help. So just hit us up and we'll get you running.
Yep. Very good. 2 more minutes.
2 more minutes. Oh my god. I can tap dance as long as you need me to. What are we doing?
1 minute.
1 minute.
All right, dude.
Then if we just, we sign off with, yeah, because I think our original estimate, if we had run it 2,000, was going to be 173 million for the 24 hours.
Yep.
So we're way past that.
We are way past that. Yeah. We were able to maintain 3 to 4K instead of 2K. Scaling up and down around that average mark, sort of, put us on average over it. But that's how we tuned the system to to favor more versus less. So we wanted to keep a buffer, and man, really
It's pretty
successful.
solid. We ran just all night.
The fact that we could go to sleep, or at least some of us could go to bed, was pretty impressive. I didn't get much sleep last night because I had this running on my nightstand. I had my phone with Danny's face doing the demos all night, and so I had that running. But I would every once in a while I'd lean over and I would see the graph is doing great. So the network's responding really well. We were all kind of nervous. We didn't know what to expect. We'd seen this in staging work, but you never know when you go to production with a performance demonstration how things are going to go. So this worked out really well. The whole dev team has spent a lot of time building out this system. So kudos to all those guys.
It's amazing.
Yeah, Adam, Alex, Reagan, Noah, Robbie, Gould, David Rigby. These guys have put in work. I mean, seriously, this wouldn't exist without those guys. So, yeah, Eric, Lance, Farmer, Todd, all of them.
Farmer Todd.
Farmer, not Farmer Todd. They're different people. Grammar, there's a comma there. But these guys are great, and that's what produced something like that.
Yes. The disappointments, Sasquatch didn't show up, and Chad didn't show up. So, but other than that,
yeah, he's remote, right? He's
Yeah.
remote. Yeah, that Sasquatch would have been great. We thought there might be a sighting at 3 a.m. or something. Sasquatch might just walk by the camera. So.
all right. I think we're past the time. We ran over 24 hours.
Is it enough time? Dude, yeah, it's
I think
9:30. Oh man.
I'm ready.
Let's shut it down.
Yep.
Let's shut it down.
Good. Signing off. We'll meet again sometime. All right.
Thank you.
Thanks a bunch.